Okay, this problem is in continuation with the last problem. So in the last problem we said a styrene can basically polymerize in the presence of BF3. BF3 is acting as a catalyst. Not only that was a cationic polymerization, a styrene can also polymerize in the presence of a radical. Free radical mechanism will happen in this case. So polymerization of a styrene also takes place by free radical. So I will have a free radical that will initiate the reaction. You have to propose the mechanism taking ROOR as an initiator. So I will wait for your reply. So what you have to do is, first you have to generate a radical. So that is a chain initiation step. And once you have generated the radical, use in the next step, that will be chain propagation step. In that step you generate another radical. In the next step again generate the first radical, so that you can have a. So let us try some idea you will have now. So first generate a radical, so that is radical generation step, chain initiation step, and then go for chain propagation. So let me solve this one. So now I have ROOR. So we have said many times, basically whenever you have ROOR, peroxy bond or OO bond cleave homolytically. So I have cleaved this bond homolytically. One electron goes to this oxygen, another electron goes to this oxygen. So I have 2 RO dot. Now 1 RO dot, so this will initiate the chain. So 1 RO dot, basically this is a chain initiation step. Now the next step is chain propagation step. 1 RO dot, this is the styrene molecule. Everybody knows this is the styrene. So if we have this molecule, this is a styrene molecule. So now this are having, so basically this is electron, not double bond. So what is happening here? I have an electron, this electron and one electron coming from double bond makes a bond, and one electron goes to this carbon. If this happens, what you will have? You will have RO and then OC, and you will have then, so basically how many bond? RO, and then I have 1 carbon, 2 carbon, and then pH. But I have shown only 1 carbon, so then pH. So basically this is wrong. So I should have shown something like this. So this should have been shown something like this. So let me pH here. Now you can understand. So I have 1 carbon, 2 carbon, and then I have pH. Whether I have dot, I will have a dot here or not on this carbon. So I will have a dot on this carbon. Are you getting or not? So you see what we have. Oxygen carbon bond I have. Oxygen carbon bond I have. So this will have CH2. Now this carbon will have 1 dot, and this carbon is also connected by pH. This is basically a 2-degree benzylic radical. pH CH2 dot. So this is a 2-degree benzylic radical. Now in the next step, the same thing. I have this radical. Now I can take another molecule of styrene. This will give 1 electron, this give 1 electron, this electron goes here. So I will have 1 unit more added. So this unit was earlier. Now CH2C radical pH I will again add. Now in the next step, if I do the same step again, I will keep repeating, and finally I will get something like this. So this will be the styrene molecule, and in this case again you will have you are repeated the same molecule. So mechanism is very simple. So what we have done is, same reaction is going every time. So in the first step I have generated 1 radical. In the next step, a styrene molecule gives 1 electron, and another molecule electron comes from the OR dot. It forms a bond, and the same process goes. So we write down, then we'll discuss the next problem. Now it's a So we have discussed two kind of polymerization, cationic polymerization and free radical polymerization. Basically there is something called anionic polymerization that also happens. So we'll discuss some reaction of anionic polymerization. So it's night time. I am feeling slightly sleepy. Now we will discuss tomorrow some more problem. Thanks God we don't have so much cold nowadays. 2 days earlier we were having so much cold. Not 2 days or maybe 3 days earlier. By the way, the weather of Ranchi is slightly good if you are in Delhi or in some metropolitan city. It's like a hell. Particularly in Delhi, what you have every time so much traffic. So I think you have written this one now. Okay, so let us go for the next problem.